So yesterday we looked at our chemical changes and physical changes, correct? And today we're going, classify matter. So we're going to go through some mixtures and pure substances. So matter can be split into either pure substances, which are elements or compounds, or a mixture, which can be separated, be a mixture of different things. So a mixture is a blend of two or more kinds of matter. It can be a compound with an element or two compounds mixed together. And there's two different kinds of mixtures. Homogeneous, which is uniform in composition and like a solution, like salt water. If you make your salt water, if you got salt water out of the ocean, would that be homogeneous? Well, a lot of times aren't there like particles floating around in the, it's a lot more dirty. I don't know. I was thinking of it as having sand in it and stuff, and that would settle down. So if anything's able to settle out of it, then it would be heterogeneous because it's not uniform throughout. Like if you got water out of a mud puddle, eventually wouldn't the dirt settle to the bottom and you have water on the top? That would be heterogeneous. The tiles on the floor, those are heterogeneous. You can see the white and dark brown specks in it. You think of any other heterogeneous mixtures?
So heterogeneous is where you can see.
Yeah, you can see the differences in the composition. The marker on the board. A salad. Oreo ice cream.
What if it's just one color? It's not.
Like what?
Vanilla ice cream.
I would say that's homogeneous. Unless it's vanilla bean, because vanilla bean has those black specks in it.
So that's
Yeah. Pretty much, yep. So matter can be either pure substances or mixtures. Pure substances can be an element, which is all the same atoms, or a compound, which is made up of several different atoms. Mixtures, we have the heterogeneous, or that says homogeneous and heterogeneous here, where you can see difference. Okay, the compounds or elements, they have two characteristics. They have to have the same chemical properties to identify those substances. So all water boils at the same temperature. All water melts at the same temperature. They have the same type of properties. And they have to have the same composition. So water is always H2O. Or if you're just looking at an element, just gold is always the same atoms. And they're the same composition. And the last part of this chapter goes over the periodic table. So we'll look at, here's some examples, some more examples. Yes, we have iced tea is homogeneous. Unless you had the ice in it, then it's not because you can see the ice. So if it's just the tea, it would be homogeneous. Stainless steel, the alloys of metal mixed together, those are homogeneous. Maple syrup. Heterogeneous orange juice or tomato juice, usually you get, if you let it set for a long time, you'd have stuff settle to the bottom, especially if you have pulp in your orange juice. Chocolate chip pecan cookies, granite, like granite countertops, they have the specks in it of different colors. And salad is a good example. Okay, so the periodic table, you guys know what it looks like. We're going to go through some different characteristics of the periodic table. There are groups or families, which are all the vertical columns. If you go down the column, those are called a group or family. We will usually call them groups. We use that terminology more. And those elements in that group have similar characteristics. They're all like group 1, the very far left group. They are very, very reactive. All of those are. They all have similar melting points. And you can kind of tell by their characteristics that they belong together. Periods are the horizontal rows as we go across. They do not have similar characteristics. They change widely. So there's different types of elements, and they're arranged in areas on the periodic table. The metals are on the left side of the periodic table. If you look at your periodic table, you should see a stair-step line that goes down. I wish my periodic tables weren't covered up. Here, I'll uncover this one real quick. This one's color-coded. So the metals, this is where the stair-step line is between the yellow and the pink ones. And the metals would be everything to the left of that stair-step line. These are all metals. Some characteristics of metals is they have metallic luster. What does luster mean? They shine. They're shiny, yes. They conduct heat and electricity, which is why they're used in wiring. They're solid at room temperature, except for one metal. Do you guys know what the metal that's liquid at room temperature is? Used to be used in thermometers. What was it? Mercury. Yes, mercury. It's silver. The thermometers we have now are alcohol. It's not. No, it used to be silver. They're malleable, meaning they're bendable. You can bend it a lot, just like the magnesium we saw yesterday. And then they're ductile. They're able to be pulled into thin wire and pulled and stretched. There's two specific metals that you need to know. Group 1 is called the alkali metals, not including hydrogen. Hydrogen is not really considered a metal. But lithium, sodium, potassium, rubidium, cesium, and francium are all alkali metals. Alkaline earth metals are group 2. Group 2 would be like beryllium, magnesium, calcium, strontium, barium, and radium. Yep. Good. And actually, I think I have this messed up. I think this should say alkaline metals, and this should be alkali earth metals. Change that on your notes. So it should be alkaline metals, alkali earth metals. Just switch those two words around. Let's change that. So here's some metals. What do you think this one is? Yeah, it looks like gold. What's this one? Copper, I would say, yeah. And this one? Maybe, but it's covering a chicken leg. Aluminum, yeah. Aluminum foil. It looks silvery though, yeah. Okay, then there's nonmetals. Nonmetals are on the right of that stair-step line. And they are solid, liquid, or gas at room temperature. There's a variety of states. They're very brittle. What does brittle mean? They break easily, so they aren't bendable. If you try to bend them, they're going to break. They have low conductivity. And there's fewer nonmetals than metals. You can see on the periodic table there. And the specific group that you need to know are the halogens, and that's in group 17, which is where it's the second to last group. It's fluorine, chlorine, bromine, iodine, and astatine. So here are some pictures of some nonmetals. This is carbon, sulfur, phosphorus, and iodine. And then there are these transitional elements called metalloids. They have characteristics of metals and some characteristics of nonmetals. They are solid at room temperature, and they're semiconductors. So they're a better conductor than nonmetals, but not as good as metals. And these are located along the stair-step line. And so if we look at, all except for aluminum. So if we look at our stair-step line, the elements that are along that would be, here we go. We have boron, silicon, arsenic, germanium, tellurium, antimony. 1, 2, 3, 4, 5, 6. Those are the 6 metalloids. You only have those 6. Some books, I'll put these in parentheses, put aconite and polonium on there, but I don't think our book does. So I'll put them in parentheses because some books will consider them metalloids and some don't. So those are the only 6 metalloids, and they run right along that stair-step line around there. And then the noble gases are group 18 on the far, far right. And they are generally unreactive because they have their octet. When we get to knowing where electrons are, they have all their electrons in their outer shell, so they are completely stable. And they are all gases at room temperature. So helium, neon, argon, krypton, xenon, and radon are all the noble gases. Okay. So you have the rest of the period. Your worksheet's due tomorrow. The worksheet from yesterday is due tomorrow. The chapter review is due on Friday, and you can use this time to work on that.